So the first thing about today is what is solving a triangle? Notice it's in quotation marks because it's got a special like math class definition. What does it mean to solve a triangle? So on your quiz or test or whatever, it'll say solve the following triangle. You're supposed to know what that means. And it means find all of the measurements. So every triangle has 6 measurements. Whether it's a right triangle or not, it has 6 measurements. It has 3 angles, hence triangle, and 3 sides, which we all know. I hope we all know that triangles have 3 sides, right? So you got to find all 6. But 3 will always be given, whether it's the work we're doing now or the work we're going to do in January. 3 are always given, and you find the other 3. I like doing a special little summary of the work. It's not just to help me. I find it's really useful for you. It focuses your thinking. It focuses your work. So I'm going to show you that. And I want you to summarize your work appropriately. You don't have to necessarily do it the way I'm going to show you, but I don't know why you wouldn't. Does that make sense? Everybody good with that? All right, first question. Remember I said you're given 3 pieces of information. The right angle always counts as one of them. It's one of the angles. Tells us it's a right triangle. Tells us we're using SOHCAHTOA. But it's also one of the measurements. So that's one. And in this case, I'm also given 2 side lengths. That's one of the kinds of questions you could get. The other kind is the right angle and 1 side length and 1 other angle. If you're only given 3 angles, you can't do anything. If you think about similar triangles that we did last week? Yeah, last week. That would make sense. Like, if all you have is 3 angles, you don't know if it's a small triangle or a big triangle. You could find the ratio of sides, but you can't find the side lengths. You always need 1 side length. Anyway, but that'll be given, so you don't have to worry about that. So in this case, we're given 2 side lengths. And we have to find 2 angles and the other side length. So here's how I like to write down the summary. I'm going to start LMN. I'll start with the angles, and then little l, little m, and little n. So again, you don't have to do this. It's easy for me because I have all the colors on the computer. But if you have a pen or a different colored pen or something like that, and you find this helpful, some people like to color code things, and that visual aspect of it helps. So by all means, go for it. I think it's a nice idea. So what I'm going to do is I'm going to put the givens in red just so I know they stand out. So that one's 90 degrees. I'm given little n, it's 17.1 centimeters, and little m is 13.0 centimeters. So those are my givens. When I fill in the other ones, I'll use a different color. You don't have to do that, but. In the case of right triangles, there's no special order that you have to use to find things. Typically, you can find any of the missing sides or angles first, so it's up to you. When we do non-right triangles, that changes, gets quite a bit harder. But for now, it is still important. Like everything we've done up till now, it said find x or find theta. So you kind of know what you're working towards. That part of the thinking's done for you. And you just label the sides and you go. But when there is no x or theta, you have to find everything. You have to decide kind of where to start with the x. Like, what do you want to find first? And in your head, you have to know that's what you're doing. So what do you want to find first? Somebody tell me. Anybody? Jaden? Angle M, thank you. And the summary tells me what's done and what's left. I have to find angle L, angle M, and side length L, right? So we'll find side length M, or angle M first. So 4M. Again, you don't have to put a title, but I think it's a really nice idea. You'll find that when you're solving, sometimes the answers get kind of big because we're going to do 3 different things. And it's confusing which one's which. You give it a little title like that, and all of a sudden it makes it really clear. And it is your job to make it as clear as possible for me or whoever is reading your work that they can understand it, right? That's part of the learning is communicating clearly. So this to me just helps. How am I going to find m? I'm going to use sine because this is my opposite and this is my hypotenuse. I'm looking for an angle, so that's like what we did yesterday. So I'm going to do sine theta, opposite over hypotenuse. Sine of m is opposite, which is 13.0 over 17.1. And m gives me approximately 49. Now I'm going to do something a little bit weird here. And trust me on this one. Like, I suggest you do the same thing for now. And then as we go through the rest of this example, it'll be clear why I'm doing this. I just want to show you on my calculator what I'm doing here. So let's do a shift sine bracket 13.0 divided by 17.1. And I got this 49.4848. So I'm going to keep a whole bunch of decimal places. 49.4848. I'm writing down 4 there. But in my summary, I'm going to round it properly like we normally would, which is 49 degrees. Okay? You would usually round to the nearest degree. Why did I keep all those extra decimals? You'll see in a second. Okay? For n. So for n, sorry, not n. What am I doing here? L. For L. You could use trig again, and it would be cosine, and that would be awesome because you'd be using the two givens, but it's a little bit extra work because I could just do this. L equals 180 minus 90 minus 49.4848. I don't really need those decimal places, but I'm going to do it for now anyway. Okay, and I'm going to enter this answer. Now, I'm going to show you this just because I've got it on my calculator, so why not? So just take a look at what I'm doing here. See how I've got this answer still on my calculator? That's the one we just did. So if you have a good calculator, you do 180 minus 90 minus answer. How many people have that button answer on their calculator? Do you use it? Do you know what it does? You ignore it? Anybody use it? It's really useful if you get in the habit of using it, I find. Because I can stick that answer in wherever I want. And I don't have to worry about rounding. I don't have to worry that I rounded wrong or that I didn't keep enough decimal places. This will give me an exact answer. Exactly the same as if I use trig. So 40.5, in this case, rounds up to 41 degrees. And those three angles, L, M, and N, add up to 180. They should, so that makes sense. So we're all good. Okay. Last thing I have to do here is, again, my summary shows me, oh, that's the last thing I have to do. I never get confused about what I'm doing. I know that's the only blank. That's the only thing left. So I'm going to type 4L. And I could use trig now that I know two angles. But if the rule was you have to use givens, what would I do to find L? Does anybody other than Jaden know? I'm sure somebody does. Jacob? Nice, Pythagorean theorem, right? Right triangle. I think we talked about this briefly at one point. Okay, good. So let's do it. A squared plus B squared equals C squared. My C squared is the hypotenuse, 17.1. So I'm going to do L squared plus 13.0 squared equals 17.1 squared. Just watch for a minute. A lot of people would start punching stuff into their calculators. I'm going to strongly encourage you not to do that. If you want to continue to be successful at math moving forward, you've got to be able to handle sort of this stuff more algebraically. So I'm going to leave everything as a square. I hope your grade 9 teacher did it this way with you, but obviously I don't know that they did. And in some cases they probably didn't. And I'm going to do this thing all together, right? Instead of each of them individually. Sometimes you can do them individually and it's fine. but this is a useful skill to be able to do that. That should not be hard. And do the whole thing in your calculator all together at the end. So what would that look like? That would look like square root bracket 17.1 squared minus 13.0 squared. Okay, 11.1090. Again, I'm done, so I don't need all those decimals, but I'm going to write them anyway just because I want to show you something. 090. And then over here, I'm going to write 11.1. These three blue ones are the ones that are rounded, so I'm going to show my rounding. I know I'm done because my, whoa, what happened? Because my summary is done. Sorry. I know I'm done because my summary is done. And I know which answers were given, which answers were rounded. Like, it's just kind of a nice little way to put it all together. Any questions? We're just going to do one more of these together. I'm going to let you sort of take some action on it. Before we do that, put your pencil down and watch. So imagine I wanted to use trig instead of Pythagorean theorem. That's fine. I'm going to do it right here. Put some question marks. Okay, so L is 41 degrees, right? We found that. If I want to find little l, that's going to be tangent. Okay, so tangent. I'm going to skip some steps here because we're just trying something. Oh, sorry. Tan of 41 equals opposite, which is L, over adjacent, which is 13.0. So then 13.0 tan of 41 equals L. Everybody, I haven't done anything weird. I promise you, if you think I'm up to something, that's right. You agree that's right? Everybody's okay with that? Watch what happens when I put it in my calculator. 13.0 tan of 41. 11.300. What was the answer we got before? 11.1. They're a little different. Big deal? No big deal? I don't know. If this was like a bridge measured in kilometers, the difference between 0.1 and 0.3 is 200 meters. That might matter. The bridge might not connect, right? If this was a missile guidance system, and you're aiming for your enemy or something like that, and you're 200 meters off, and you hit a school, that's bad. I hope you agree that's bad. If you're working with, like, I don't know, wood or something, and you're off by a couple of millimeters, that's not a big deal. Wood's very forgiving. That would be fine. So my point is, it depends. Like, rounding and how close you are depends on what you're doing. But I think it's important that you know when your answer is going to be exact and when it's not. So we're going to go for exact answer. So if you gave me 11.3, you'd lose some marks, or a mark or whatever, because you made some bad choices along the way of what numbers you used. So the whole point of this is, if you use givens, Pythagorean theorem, you'll always be fine, never have to worry, nothing bad will ever happen. If I use a rounded answer, like 41 or 40.5, there's a good chance I'm going to be a little bit wrong. Sometimes you might be fine, sometimes you might not. If you keep 4 decimal places and use those, you're always going to be fine. I can guarantee you 4 decimal places is enough to make sure that the 1 decimal place will be correct. Or, if it's possible, use the answer button on your calculator. If you just did the answer and it's still stored there, use that. These are just good habits. They will make your life a little bit easier in some cases. And I want you to know when your answer is perfect or when it might be off by a little bit. Okay, let's try the next one. This question is slightly different because the last one gave us two side lengths, this one side length and an angle. Once you've done both types, I think that's kind of it. After that, for SOHCAHTOA stuff, they're all pretty much the same. This will really mess some people up. All right, so I'm going to fill in my answers here. B is 90. Angle C is 19. And little c, oops, that's wrong, sorry. Angle C is 19, and little c is 30 kilometers. People think a squared plus b squared equals c squared. So they think this always has to be c, but that's not true. It's a tricky thing, but like, that's a formula, ABC. The ABC in a question will not always be the same ABC. Sometimes it's XYZ, sometimes it's LMN. Like, that doesn't matter. C in a question isn't always the hypotenuse. But in the formula, it is. Okay, so anyway, just think about that. Kind of interesting that in this case, my hypotenuse is little b, there's little a, and big A. Those are the three things I have to find. What do you want to find first? Angle A, thank you. Good choice. Why? It's super easy. 180 minus 90 minus 19. What does that give me? 71. Folks, notice that's an answer I found, but it's not rounded. It's just as exact as everything else. So there's absolutely nothing wrong with using that for the rest of the question. All that stuff we were just talking about using givens and stuff, A would be fine to use. Right? I didn't have to round. Okay, I want you to go ahead and try to find either A or B. Actually, both. If you get one done, you can keep going for the other one as well. All right, how we doing? So, there we go. Those are my two. I haven't put the answers yet. For A, I use tan. Again, I use the givens because it's just, to me, it just makes life simple. Sure, I could. Is this gonna work? What's going on with this thing today? I could use angle A, which is 71, but I don't know. It's just some people get confused by that. 19 is on my diagram. I'm given 19. Just use that. So opposite of 19 is 30. A is adjacent, right? B is the hypotenuse. That's tan. So I use tan for A. For B, again, opposite is 30. B is hypotenuse. Which ratio is that? It's sine. So you sine. Good luck. Who do you play today? Good luck. Okay, so you sine for B. Sub in to the right spots, hopefully. Rearrange. Solve. What's the answer for A? Can somebody give me that? Who's got that? Jaden?
You got 87.
87.1 and B. Somebody else have B? Yeah, Rip and Pre. 92.1. 92.1, da 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 da. In this, I told you 4 decimal places, but I knew, like I already had both of those set up without an answer. I'm not using them for anything, so I don't need the extra 4. When in doubt, keep more decimal places, write them down. It only takes a second. But if you know you're not using that answer, then you don't have to do that. It's all about, and again, I'll put units when I put it into my summary. You don't need to write units in both places. Okay, it's all about making sure you get the right final answer. It's not a make work project. You don't write down extra units just for fun. It's just to make sure you get the final answer perfectly. In this case, I didn't really need it, so I didn't worry about it. Any other questions? There's one more here, but we're not going to bother with it. I'm going to let you guys practice on your own. Okay, so the work is the odd ones for all of this worksheet. I'll leave these first ones up. So you start with A, B, C, and then do G as well. I can only leave those ones up on the screen. Okay.